Today, we'll walk through 4 scenarios: false positives, crawler bypass, count to block evaluation, and injection attack analysis. Let's start with false positives. This time, we look into the second WebACL. It delivers logs to an S3 bucket instead of a CloudWatch log group, so you can see what Athena query speed is really like. Because Athena queries take a moment, each time window is capped at 1 hour. If you need to cover a longer period, you run it 1 hour at a time. Alright, the agent finds a candidate IP, but the agent doesn't know your business. It can confirm a false positive on its own, so it asks a couple of follow-up questions. I ask it to investigate this IP further. Athena queries are slow, so let's wait a moment. In a production environment, there are way more logs than this, and Athena queries take even longer. That's why you should partition your logs by the minute. Okay, the agent gives me more details. The blocks happened on the search API endpoint because the query strings contain union and select, classic SQL injection keywords. I tell the agent we are a financial services company, so people searching for credit union is expected. The agent finally confirms this is a false positive. It searches the knowledge base for scope down statements and show me in detail how to fix this with a scope down statement. Now I ask the agent to check if any crawler is bypassing the WAF. Most WAF analyses look at what got blocked. Bypass detection does the opposite. It scans the traffic that was allowed and asks which of it doesn't look human, like one IP hitting too many URIs, automation tools, or one TLS fingerprint spread across many IPs. The agent finds a suspicious distributed crawler getting through. It also notices my WebACL doesn't have bot control configured, and suggests I investigate the suspicious IP further. I say, go ahead. Then the agent starts the IP investigation and J4 analysis in parallel. Yeah, Athena is really slow. So here's a tip. If the tool sees your logs are partitioned by the hour, the default for Firehouse, it just stops and tells you to switch to minute-level partitioning first. Otherwise, these queries could time out. Okay, there it is. The agent confirms it's a probable distributed crawler because many different IPs all share a single J4 fingerprint while faking a real Chrome user agent. And since bot control isn't deployed, the WAF has no real way to catch this. So the agent suggests deploying targeted bot control. Also reminds me that it requires the client SDK. I'll move on to the count to block evaluation scenario. The idea is simple. If a count rule hasn't fired in the past 2 weeks, it's safe to switch to block. Otherwise, the agent digs in before making a call. Here are the results. 2 rules can be safely switched to block, but cross-site scripting query argument needs a closer look. The agent first uses CloudWatch metrics to pin down the peak time window, then queries the logs to cross-check for false positives. Now it's checking a few of the top IPs. Finally, the agent confirms these are real attacks and lists the XSS patterns it found. Here's the thing. Except for a few rule types, AWS WAF doesn't include the metadata in the logs. That makes it really hard for humans to judge whether a block is a false positive. But this is exactly what AI is good at. Last scenario today, injection attack analysis. The agent starts with CloudWatch metrics to see which rule is firing the most. After that, it hits the logs for 2 things at once: which paths are getting attacked and where the traffic is coming from. The pattern looks the same across the paths and IPs, so now it zooms in on the top source IP to profile it. And this is the slow one. Profiling an IP means several Athena queries, so this takes a while. It checks the request rate, the URIs, the IP hit, its fingerprint, and the payloads it sent, step by step, narrowing down each time, instead of querying everything at once. It's how a human analyst would work, just faster. Okay, now it has everything, and it puts the whole picture together. The agent confirms the SQL injection attacks and ties them back to the same attacker from before.